Here is our Unit 2.2 two-column proof video. Now, up till now, you probably have not done a proof, so I'm going to try to make this as short as sweet as possible. Proofs can get crazy. Proofs can be pretty simple. It all depends on what type of problems you're working with. But I'm going to go ahead and show you here on the screen. This is what our two-column proofs are going to look like. On the left, we'll always have statements. On the right, we'll always have reasons. No, you don't have to draw a table like that. You can simply draw something like this, and then put all your statements over here and all your reasons over there. You don't have to actually make it look like a table. I'm just trying to show you. So I got some organization here, so that's all I'm showing. So the type of what's going to go in a statement is our math process. Like showing our work almost, but it's a little different. I'm going to get into a problem here in a second just to try to relate what it's going to look like. And then the reasons, so the statement are what the steps were taken, the reasons are showing our work, but now it's not showing work. Now it's not, instead of showing your work, you're trying to tell them what you've done, what you did. And here are some properties that we're going to be putting in the reason statement. So addition property of equality. I'm just going to go ahead and say addition prop because we don't have to write it all out. Addition property of equality is our easiest one to see. It means to add to both sides. The subtraction property of equality we'll call subtraction prop. It means to subtract to both sides. The multiplication prop, multiply to both sides. Division, divide to both sides. Combine like terms is to combine like terms on one side together. Distributive property, you all have seen distributive property with the parentheses. Symmetric property just means to flip it. So if X was on the left, we could flip it to the right. And you'll see it, and I'll get to it, and you'll see examples of it. And simplify just means that I could have simplified one side. So I know this is all new, and it looks really different than a lot of things we've done, so I'm just going to try to relate to something like this. So I'm going to use this process here, this equation here, to try to set up proofs for you. So here's what we're going to do. So here is the equation, something similar to what we did last week with, and so we got 4x plus 40 plus 2x plus 60 equals 340. Here's my second step. Okay, so how did I get to this second step? Is that the red marker I'm about to put on the screen is us showing us our work. So what I did was I kind of combined these like terms and these like terms to get to this. Okay, so that was my first step. So here I am here. So look at how did I get to the next step to this level is, well, we just would have said this. We subtracted 100 from both sides to get this result. And then if I had this next problem, how would you get to the final answer is that I divided by 6. So that's your traditional math problem. So how can I relate this equation and process to a proof? So basically what a proof does is a proof doesn't show any work. So here's my equation. So the first step of every proof is to write your equation and to say that this was what's given every time. So this is how we're going to start every proof. Okay. So let's look at this second step. Okay. So what did they do? What was done to get to here? So what was done was they combined like terms. And that's exactly what I can put, combine like terms. I'm running out of space, so I'll just put combined time, like. So, and that combined like terms takes away all that red ink that was there. So let's see, how did they get from here to here? What did they do? The result, they got this result by the subtraction property. They subtracted to both sides. So there's that. And then how did they get this result? What did they do to both sides? Is they divide, division property. So that still could have been confusing, but here's how I talk about a proof. A proof is what you're doing on the left, your results on the left, and how you got those results are on the right. So we're not showing any work. We're basically writing results and how we got them. So here's a really big question. Here is a, let's see. I think this. All right. So here is a pretty, not a too big one. I decided to do a smaller one. So here's an equation. Here's what you have to prove. So you always got a given and a proof. So you're given this. Show me that it's supposed to be x equals 14. Well, what's nice is they give you the first step already. So the first step is to write your equation, and we write given. And this is your last step. So here's my last step, x equals 14. So all this is what we need to do. So we would, if we're only looking at this side first, so we say, here's our equation, here's what's given. What do we do? What would you do to both sides is I would probably move the 6 over to both sides. And what did they do? So it looks like they took this 2 and they moved it over. So how did they move it over to both sides? They subtracted 2 to both sides. And this is our result. So here's our result. And they subtracted from both sides to get that result. Okay, so here is our equation now. What would you do is, I think everybody that's watching video would say, well, we're going to subtract this 28 to both sides. And look, that's what they did. Here's the negative 8x drops down, that negative 84. If I was to subtract 28, this is the result I would get. So again, how did we get to this spot is we subtract it again. Now, in the last step here, we would just divide both sides by negative 8, and we would end up with x equals 14. And how did we get to x equals 14? As we did the division property of equality. Of equality means you do it to both sides. So if you, I subtracted or divided the negative 8 to both sides. Anytime you see of equality means it has to be done on both sides. So keep this video as short as possible. Let's go on. So this is what we'll see. And in the next 2 examples I give, I'm going to have just these properties out here. So here is, and I'm going to go kind of fast to save time on this video. If I go too fast, pause it. So look what they do. So every time we get it, we say, here is our equation, PAL. There's my number 1 step. What do we put inside here? Is we always say given. So that's how we always start. Prove has to go at the end, okay? All right, so take a look at my problem here. How did I get from here to here? I hope you see it, but here's some properties I can use. Here's the properties we're going to use majority of the time for algebraic proofs. And this one, I hope you see the distributive property. So I could say distributive property of equality or prop, okay? So what did they do to get from 2 to 3? It looks like we just got a combine of like terms or maybe a simplify. Because they're not variables here, I'm going to go ahead and say simplify. And I only simplified on one side, so I'm not going to say of equality. Because it's only numbers, I'll simplify. When I combine like terms, I'll say combine like terms. Okay, so how did they get from here to here? Looks like they moved that 11 over by subtracting it, and I would say the subtraction property of equality, but I'm just going to say subtraction prop to save some time. Then the last step would be division property. I hope that wasn't too bad. If you need to pause, but I'm going to move on to try to cut this time down. All right, so here's another one. Okay, we got a mighty big equation here. Let's try to catch and see what they do. So here is our first step. Always the first, here's our equation. Always the first equation given. Okay, always. And every time, and our answer needs to go last. Okay, so take a look and see what they did. What do you think they did on both sides? Did they do it on both sides? They did do it on both sides. They did the distributive property. So I hope you catch that, distributive property. They distributed on both sides. Okay, so coming down here, what they do? Well, I see that the only change I see is this right here. So let's see, we call it simplify. Again, I'm gonna change that because I'm gonna try to stick to here. I'm gonna say combine like terms. Because I said earlier, we're going to simplify with numbers, combine like terms of variables. Okay, so let's see. Only thing I see a change is with the variables, and this 5x is gone. So I would say on this problem, they subtracted 5x from both sides, and that would get you that -3. So 2x minus 5x gets you that -3. So here we would have this subtraction property of equality because I subtracted 5x from both sides. That's why it says of equality. Okay, and then now it's going to, I think this equation gets pretty simple now. We're going to add 5 to both sides to isolate the -3x, addition property of equality, and to get x by itself, we would divide, and that makes division property equality there. So I hope that helps. We're going to do some simple ones together. We're not going to get too crazy. And that's the end of video 2.2.